My name is Sam. I'm based in San Francisco, so it's nice to be back in England, drinking good cups of tea and eating nice curry. You wouldn't believe what they think fish and chips is back in America. So I've been at GitHub for 3 years. 2 of those years, I worked from Newcastle upon Tyne, up north, and I moved over to America in October. I'm going to talk a little bit about GitHub, first of all. GitHub is how people build software. It's where the world comes together to collaborate on open source. It's the world's largest collection of code and the world's largest collaboration platform. Alexa ranks us as being the 60th most visited site on the internet, which as a community shows that we're all growing among very large consumer-facing sites. As an industry, we're growing and technology is becoming more important, and GitHub is becoming the place where a lot of that technology is built. We have over 15 million users collaborating on 38 million projects and bringing together around 32 million gists on the site. Now, where do we work? So, as I told you, I work in San Francisco out of our headquarters. We have a few offices dotted around the world, Boulder, Colorado, in Amsterdam. But most of our company is distributed, so 55% of the company work remotely. And as I mentioned, I worked remotely for my first 2 years at the company. So this is our team application. It's an internal tool that we use. And you can locate where other employees are within the company. Drill down, you can see that we're fairly well distributed across the globe. One of the benefits of having a distributed company and a company that that kind of doesn't really bias towards where we hire is diversity. So we can hire diverse teams. We don't have to hire just out of San Francisco. So San Francisco is not a particularly diverse city, but there's people all over the world that we want to work at GitHub, share their ideas, and join us in building the place to collaborate. It's a fairly controversial subject in the industry. It's not controversial at GitHub. It's something that we care very strongly about. We're dedicated to building strong and diverse teams. I think this is something that's really important. Software is changing the world. The momentum and the power that technology drives and the force of change is important. It's just not in the hands of white men, that everyone, and it should represent everybody. And people should be able to build technology for their communities that represent them. And by building diverse and inclusive companies, we help with that efforts. If you don't want to build diverse teams because it's simply the right thing to do, then you can look at the research. So McKinsey and company show that gender diverse teams outperform non-diverse teams by 15%, and ethnically diverse companies outperform by 35%. We recently released our diversity numbers that, although good by industry standards, are still not great, but we're working on this. We hold ourselves to a high standard. We're making progress, but the work is never done. I'm sure we've all heard the word scale time and time again when it comes into technical talks and we talk about the industry. I'm just going to talk about how I view relative scale and what scale means at GitHub. So GitHub is by no means a large-scale web app. We're in no way the scale of Facebook, Google, Twitter. We're running a Ruby on Rails application, sort of a medium amount of traffic through the web. But in the Git stack, we are, by an order of magnitude, the largest Git host. And so we're running into new problems every single day. We are pushing the boundaries of that technology. And by doing that, and as every day progresses, and as our software footprint and our storage footprint gets bigger, we come up against new problems. And those problems are on us to solve. And that's where we believe our scale comes in. Our scale is unique to us, and it means we're solving new problems that are fairly unique to us. I'm also going to give a shout out to our hardest working employee, Hubot, our chatbot. I'm just going to get a show of hands, actually. How many people either use Hubot or have interacted with Hubot? That's wonderful. I'm seeing more and more companies. As I go around the world and as I speak to people, I'm seeing more and more people that are telling us how excited they are about interacting with Hubot. Large companies, even large enterprises are starting to pick up that way of working. We use Slack. There's companies using Slack, interacting with chatbots all the time. And we can do various different things with Hubot, and Hubot is the center of our culture. So for example, you can ask Hubot for a picture of a unicorn. You can do very fun things. We can ask, there's a food truck park 2 blocks from our office, and you can ask Hubot what trucks are there today, and he'll tell us, and we can go and go and get nice food trucks. You can do sort of mission critical and business critical stuff through Hubot. So this is me asking for a performance graph. And the great thing about this workflow is that it brings the context into chat. So by having a remote and distributed workforce, we have people working from home, working on various different time zones. We're not sat next to each other in the office. We can't just go and show each other our screens or drag our laptops over. And even in the office, we don't do that. Our culture is, if you have your headphones on, you don't want to be disturbed. So you sit at your desktop, you work, and quite often I see two people chatting away at each other, collaborating together, sat next to each other at a cafe table inside the office. Because it's not just about who is with you in person, it's who's with you in the chat room. So you include your teams. So I can drop into one of the infrastructure organization's team rooms and have a look, read back the chat log, get the context, and it's the place we work, it's our office. So we quite often, we'll pull up graphs to look at performance, and you can share it among the teams. People can see what you're doing. People notice things. One person will be looking at a graph, someone sees something else, we have a discussion, we chat it through. It brings everyone together. You'll also see the red lines that go along this graph. They're deploys. So we deploy our applications hundreds of times a day, and it all happens through chat. So I'm sure a number of people here have had the experience of going to their own site, looking at their own infrastructure and seeing that there's a problem. And then they have to backtrack very quickly to find out what change was made. You have to wander around the office, ask, look for things going on. But with this way of working, you just drop into chat and you actually see the deploy, and you see who's done the deploy. You can see the feedback from those deploys and see those results. This is how we deploy from chat. So first of all, you would queue yourself. So during the San Francisco workday, it gets very busy inside our chat room because we do have a lot of developers on the West Coast. So we have a queue, essentially. You sit in a queue, and Hubot will ping you when it's your turn in the queue, and you essentially get production to yourself to deploy. And we have that per application. The main application that sees the congestion is GitHub.com. For some of our other applications that we deploy via chat, like Puppet, a lot of our C code bases, every application that runs on GitHub is all deployed via this way. They're less busy because they're not as high traffic for our developers. So once you're up in the queue, you would deploy your branch to production. If you went to github.com now, I could guarantee you wouldn't be running on the master branch. So the way we work is we iterate, we use pull requests, and we use a branch workflow. So as my last speaker mentioned, it's good to do small and atomic commits, and I agree. We spike out a pull request very early. Quite often you spike out a pull request with just the empty file structure, essentially, of what you're building out, some empty files, and then you state the intention of what you want to build in the pull request, and that invites in collaboration from everybody. So you talk about what you want to build, and you bring the people along with you in the journey in that pull request. When I talk to the teams that I mentor, I'm very specific about pull requests showing the journey of what you've built within your software. We allow you to embed images. You can get your CI statuses pushed back into pull requests. You can see the history as we track through a feature. So you spike super early. We've had pull requests that have ran and continuously ran for 11 months, that with constant change, constant iteration, you can drop task lists in so that when you know how you want to deploy the feature, you can link to other milestones and other references. And it's a wonderfully empowering way to work. And I'm not just saying this because I work at the company that builds this software. Quite honestly, it's amazing. So when I joined GitHub 3 years ago, I joined as the first DBA working on our MySQL infrastructure. And I was able to look back at what the early engineers at the company had done and look at the work and, most importantly, look at the decisions they'd made. So I would find a variable in a config file and I think, this looks a little bit strange. Like, why have we set this one? And I'm able to go back to the pull request, to the issues, look at the graphs they put in that pull request that introduced that config change and get the context straight up and just understand it right away. And it's like traveling back in time. And I do it with pull requests that I've made and issues that I've posted to bring myself back to where I was making that decision. So we love this workflow. I'm going to talk about the infrastructure organization specifically. So infrastructure lives within our greater engineering org. We have 35 engineers broken down into 3 groups. We have the storage engineering group, and they essentially manage persistence for the company. So we have the database team that manage MySQL databases, Redis, Elasticsearch, and they're very much a DBA team, a team of SREs that build automation and workflow tooling for our developers to use for our database tier. We have the Git core team. So the most prolific committer to Git works at GitHub, and he manages the Git core team. And he spends most of his time working on Git core, enhancing that community, security releases, features within Git. And he doesn't really do too much for the company itself. If there's specific things we look for in Git, he will prioritize that on his roadmap. But mainly, he's working on Git core. We have the Git infrastructure team, and they do Git applied to production. So they run Git in production at GitHub, and there's 7 people who do that. It's a very large tier for our persistent storage layer, and we build things such as custom proxies. So when you do a push to GitHub, we intercept that request through a proxy that talks to MySQL and authenticates you and then passes you through to the file server for you to actually talk to Git. We have rate limiting software so that you can't overswamp our infrastructure because we're multi-tenant. We run up to 400,000 repositories per server, and we don't want users being able to knock out other users, so we can rate limit you across our infrastructure. We can do various amounts of caching, all custom to Git and the Git stack, and that team manages that. We also have the Git ecosystem team that work on things like large file, LFS for Git. We have the data center engineering team, fairly self-explanatory. They build out our data center footprint. They build our physical infrastructure and our physical machines. We're able to deploy physical machines as if they're the cloud. If you go to our engineering blog, githubengineering.com, you can read blog posts about how we do this. Essentially, you ask Hubot for a server of a specific chassis type with this role, and Hubot will go and provision that for you. It takes less than 10 minutes to provision a physical machine. And so we gain that kind of cloud-like flexibility. But the Git workload and our database workloads that are very performance intensive do not run well on the cloud, so we run on our own machines. So that team managed the provisioning of those machines and growing our global footprint. And then we have systems engineering. They're the organization most like an SRE team. We don't really run like ops in a traditional way. I wouldn't say we do DevOps. We work towards a more SRE model, but we build a lot of automation throughout our stack. We try to eliminate any manual process that we would have, and that's what that team does. So I believe it's important for every culture to have a form of philosophy, whether it's implied or written down. With a distributed and asynchronous company, we favor writing things down. And so I'm going to cover some of the values we have as a philosophy within infrastructure, and I'm going to take some snippets from that philosophy. So above all else, GitHub is a Unix shop. We create programs and tools that follow the basic principles of Unix: simplicity, modularity, and composability. We believe that it is always easier to add complexity than it is to remove it. So this is something really important. You can really quickly build. I have no doubt that any of you can build things very quickly. I have the doubt that you can remove it from production as quickly. We're excited by new tools, but we never use them just to use them. We experiment, but we'll always prefer what is proven over what is new. So I'm going to explore this a little throughout the talk, but the general theme is simplicity. We drive within leadership at GitHub, we drive the need for simplicity because we're moving very quickly. We don't want to grow our company, like a developer footprint massively just to keep up with technical debt. We want to grow slowly and pragmatically, and that's why being rigorous and using simple and proven technologies, we drive complexity out. So why? Why is this focus? And I'm sure everybody would say they want simplicity, and at a glance, you'd assume that's what everyone wants to do. But I don't know if that's the trend in technology at the moment. You know, if you go to Hacker News or some other news site, you'll see that complexity is being built up all around us. The question is this wrong? I don't think this is wrong. Everyone is welcome to their approach. But it does come back to a choice. And as an industry, I think we at least serve us to question this approach. Excuse me. So I'll talk a little bit about our stack. Our stack is pretty simple, but continually evolving. We run Go, Ruby. GitHub.com is a Ruby on Rails application and a monolith. Obviously, we have a lot of Git, Shell. We have some C applications just purely for performance reasons. And we try and drive pragmatism in our technical choices. You know, there's new technologies coming up all the time, but we pull them off the shelf. We're pragmatic about what we want to pick from our technologies and also what we don't want from new technologies. What do we get from this approach? Well, We get sleep. It's a lot easier to run stable services in production when you know how they fail. We want predictability. It's not about if failures happen, it's about when failures happen. They're guaranteed. It's definitely going to happen. But you want them to fail in the ways you understand. You don't want new and novel failures at 2 in the morning when you're tired and you're having to deal with production and debug issues. I want to explore what the right tool for the job means when building a new technology, when working in technology. It's a word that's often overused. I think you can easily find that brand new technology that's specifically picked for that one use case and is optimized for that use case. But it might not always be the best choice. It's useful to look back and gain community knowledge and understand what the community is doing as well. If you can take a technology you've run in production for years and adapt it to a new use case that you have, there's opportunity there to continue building on that older technology and building on that stack that you understand. Even though it's not purely optimized for that, you get that social and cognitive win there from that. So I'm going to take database example. Database engineering is something I'm passionate about, something I really understand. And there's a trend with databases at the moment, which involves your databases just abstracting all sensibilities from you. We have a lot of no SQL databases in the industry. They don't force you to think of a schema up front. They allow you to do anything. They manage failover for you. They manage your connections. They manage load balancing, sharding, replication, all these various things. And I would argue that that's too much for your database. Your database wants to store and retrieve data quickly, and you can build around that. There's stable proxies out there in the industry that you can use. You don't necessarily have to have everything doing everything. So because you're just going to, all these things dilute what you want from that core technology, and it builds up that complexity, and it just introduces way more surface area for failure. Let's take MySQL as an example. MySQL is a 20-year-old software project, excuse me, that still powers the largest sites on the internet. If you look at the top 100 websites, you're not going to find many that aren't being powered by MySQL. And it cares very little about doing much extra. It really just does reliably store data, replicate it for you. Thank you. I seem to have picked up a little bit of a cough while traveling. And we're going to talk about the monolith a little bit as well. We still run the monolith. By the way, best film of all time, I think. We use a Rails monolith in production because pragmatically it still serves us. We're an 8-year-old company. We still want to build software and services quickly, so our monolithic application can move around with us. But will it last forever? Definitely not. It's starting to creak. For those of you running Rails in production, you'll know that it's not quick. But we have core Ruby maintainers on staff, and we also have Rails maintainers on staff. Pragmatically, we can pay down the operational burden of Ruby on Rails by hiring people to actually work on some of the core issues and still move fast within our product. So pragmatically, Rails still serves us. It's creaking, we're moving some things out, but that's an evolving process, and we're doing it pragmatically, and we know why. Our graphs are telling us what we need to move out, and when we break things down, we do it by the application telling us where our hotspots are, and by moving them out into smaller services that are better extracted, and we understand those interfaces. Why do we, so I just want to explore why I think we naturally build complex systems. I think we see software development as being inherently complex, and we use that as an excuse for our software being complicated, which is the opposite of elegance. Elegance is solving complicated problems with simplicity, and I'm going to give you a great example from the town in which I live, San Francisco. We have the Golden Gate Bridge, which is it's achieving this amazing feat of engineering, something that's extremely difficult. It spans a 1.7-mile gap across the bay and is 746 feet high. But you can pretty much draw a representation of the bridge within 6 lines. And I think this is why humans are attracted to this. Like millions of people from all over the world come every year just to look at this bridge. And I think that's what staggers us. It's understandable and it's elegant and it's simple, but it's complex. I've done some art to illustrate how simple it is to represent the bridge. There's those 6 lines. I'm very proud of that one. talk a bit about innovation and what simplicity buys you for innovation. You have a finite amount of resources in any company, no matter how successful you are. And I believe you should be trying to spend your time doing the thing that your users are coming to you for, and that's building your product. If you're sleeping well because your technologies are running and they're not obscure and they're not weird, you can spend your time innovating and building the thing that's unique to you and the thing that you want to build and that the market is coming to you for. So what are the roles of new technologies? So I'm not a Luddite. I'm not trying to say we stop, we close the doors now and it's all done and we give up. And there's some amazing advances being made in technology. But what is that role and how do we reflect on those as people that want to be pragmatic and use simple technologies? I think they push us to look at the way new problems are being solved and reflect on our own solutions with these new solutions that are coming up. And people are doing amazing work in the open source communities. I still encourage people to look and play. That doesn't mean throwing it into production tomorrow. I'll go back to another example, which is MySQL and JSON. So Postgres a while back added JSON columns. We have a lot of JSON databases around, like MongoDB, and it took 2 years for MySQL to add JSON columns. It's something we're experimenting with in production, and the point is their development process, the development cycle for MySQL is very slow. It's 2 years between major releases. And the reason is because then there's the thing that we go to MySQL for, they will not compromise on, which is stability and data safety. So they will get these new features in time while we remain stable and safe with our data. It just takes that time. And really, there's no approach you can't borrow from. You're not missing out. You're just waiting, and you're buying that stability in, and you're waiting to use these new approaches as time goes along. I just want to use a quote, and I'm going to talk about a small project that we have internally called Brewback. It's open source. It's a replacement for Etsy's StatsD that is written in C. We hit that performance scalability with Node.js. I just want to share a quote from one of our engineers, which sort of sums up our culture quite nicely. The Brewback's feature is that it has no features. It is a very simple C daemon that uses a state-of-the-art technology such as a while loop and more than one thread. I'm going to tell you a story about GitHub Enterprise. So we practice what we preach, and we have a practical application for this that is huge for our business, which is GitHub Enterprise. I don't know if any of you know, but you can actually bring GitHub in-house. There's a number of companies, large banks or people that they cannot, for legal reasons, give us their data and their code and their intellectual property. So they would run GitHub internally within their own infrastructure. And GitHub Enterprise, as you can see from our workflow, we're always developing, always iterating, we're always moving out onto production. But GitHub Enterprise started to drift. The project blew up and became very successful and went off like a rocket. But it started to take a lot longer to get releases out because it was out of our way of development. We'd be like 8 months behind what the features were on github.com because it would take 40 minutes to build a GitHub Enterprise box. And developers that are used to being able to be on production within minutes of pushing a branch up aren't going to sit and wait for 40 minutes to test their stuff on Enterprise. So we had this divergence. Now, the Enterprise project had grown massively and ended up spanning like 6 repositories. It was like super DevOps. It used all the new orchestration tools. We had Chef. We had everything built in there. Highly extracted. You could say it was like great, but it was slow and it wasn't easy to build. It was hard to understand. So we rewrote the entire project, which is rare to be able to do, but we rewrote it completely in Shell because Shell gives us exactly what we want, deterministic commands that build a box. So the entire rewrite of GitHub Enterprise now brought us down to being able to build within 2 minutes, down from 40 minutes, by just using simple technologies and reducing complexity down to something that all our developers understood. And that brought us back in line with our workflow. And now people wait a month to get features from github.com into Enterprise. It was a big reduction in complexity for us and allows for a lot faster iteration. I'm running out of time, so I'm going to very quickly talk about one project that we used that's halfway between a distributed system and just the natural use of Git. So the way Git used to run up until 2 weeks ago, which Spokes, our project, is now 100% on production. Every single repository you interact with on github.com now runs out of this Spoke system. But before that, we had very simple stack. We basically had vertically scaled machines with DRDB between the two. You would write to the primary node, and it would get replicated over to the replica node. And if we had a failure, we would lose around 400,000 repositories per node for up to 20 minutes while a human had to come and respond, fail the node over, work out some really jank DRDB error messages usually, and we'd have to status so that our users would, they'd see the outage, they'd understand why their repositories were unavailable. There was good and bad to this approach. It lasted us around 7 years before we started the dgit project, allowed us to grow as a business, and pragmatically worked. We vertically scaled machines, we paid down the problem, we didn't get too complicated too early. But this is where we did what everyone does in this situation and build their own distributed system, and this is where it can get really complicated. So we introduced Spokes, which is really smart and really dumb at the same time. It's a project that allows us to replicate Git into 3 places, and it makes Git storage aware. So Git doesn't understand where it's being stored, it just sits there, it doesn't manage its storage, it's not aware. It just sits on a machine, so we had to abstract all that failure with RAID and failover. Now, if we lose a node, we have 3 other copies, and this means that we actually take nodes down in production continually for testing without interrupting any user operations. And we did this by building a 3PC client on top of Git and using Git for exactly what we need it for, which is data consistency out to the various nodes. So it's just Git and 3PC, super simple. We could have used Raft or Paxos or Zookeeper or tried storing objects in Cassandra, but Git itself has consistency, so we just kept it simple with Git and 3PC. It gave us flexibility and fault tolerance. Last subject I'm going to talk on is organizational simplicity. So I'm sure there's a number of engineering managers in the room, people that lead, and organizational simplicity is something that we're really specific about. We don't vertically scale our teams. We use 2 concepts, evergreen teams and workflow teams, work queue teams. This is an old organizational design philosophy that we have introduced into GitHub, and I'll just cover those for people that aren't familiar. So we have evergreen teams that stick to a specific area. So we have like the Git infrastructure team that we're continually working on Git infrastructure. But within systems, we have workflow queue teams that are small, composable units that work as groups on larger projects together. And the reason we do that is because if you vertically scale your teams around features or small areas of your organization or your stack, you lose flexibility. So the highest priority project for one team might be priority number 30 for the entire organization. So we scale our groups around groups of people that like to work together and have similar complementary skills, and we just view them as queues, and they are capacity. So you have these composable groups that can move, work with various different directors, work within the organization, and shift around as a small group. And it's kind of Unix here. It's composable, it's modular. We don't have to make vast organizational changes when priorities shift. It's just groups, small groups of people that move together and have their flows within their teams. I'm also going to talk a little bit about management in GitHub and bust a myth that is around. We used to have no managers. When I joined GitHub, there was absolutely no managers. But now we do have managers. We have a structure. We keep it structure light, and we don't overemphasize the need for our structure. We use it for communication and to allow people the freedom to know that they are working on things that are high priority because communication is streamlined. Our management roles at GitHub are very technical. I believe to be an engineering manager, you need to be very technical. We say we require our managers to write code for around 80% of their week. We view doing code review and mentorship and guiding projects as management, and it involves being the engineer, being that lead engineer that you've always wanted to work with, and guiding people towards technical solutions. And you find that it's easy to manage people when you're enforcing the needs and allowing them to ship and giving them a quick iterative cycle towards production. Lastly, I'm just going to share my tips on management, and it's very simple. Get over yourself, have hard conversations, and get a therapist. So I believe that management can be very simple if you look at the fundamentals of what human beings want to do and want to do at your organization. So a lot of the time when I speak to managers and end up mentoring managers, a lot of the conversations and a lot of the sticking points they're seeing are not with the person they're managing, but with themselves. And they're usually blocked on having a difficult conversation, saying what needs to be said, and looking for that common ground that you both have. And also get a therapist. It's the best thing I ever did. It's quite stigmatized in the UK, but in America, everyone has one, and it's fantastic. It's really good. If you are looking after people's health and well-being as a manager, you should be doing the same for yourself, and it's just like attending a gym for your brain, and it's wonderful, so I recommend it to all of you. And I'm going to leave you all with a question. Are we strengthening our foundations as an industry, or are we rebuilding them time and time again? Do we want to build on the past and the knowledge we have for the past, or do we want to clear it away year on year? So I'm pretty much done. I think most speakers will usually probably pop their like social media stuff. I'm not going to do that. I'm going to encourage you to follow these people instead. I'm sure you have enough boring white men in your Twitter timelines, and you should go and follow these women that speak about technology and also very wonderful people. And that's me. Thank you very much.